Problem 4. Using factoring to solve a real-world problem. Photography. You are constructing a frame for the rectangular photo shown. You want the frame to be the same width all the way around and the total area of the frame and photo to be 315 square inches. What should the outer dimensions of the frame be? Consider the photo, the measurements shown, and consider what you know. You know the size of the photo is 11 inches by 17 inches. The total area is 315 square inches. Consider what you need. You need the outer dimensions of the frame. And so your plan? Write the frame's outer dimensions in terms of its width, x. Then use the dimensions to write an equation for the area of the frame and photo. So to begin with, area equals width times length. In this case, our width is 2x plus 11, and our length 2x plus 17. Then we find the product of the binomials. 4x squared plus 56x plus 187 equals 315. Subtracting 315 to each side, 4x squared plus 56x minus 128 equals 0. Factor out a GCF of 4. We now have 4 times the trinomial x squared plus 14x minus 32 equals 0. And then factor the trinomial to arrive at 4 times x plus 16 times x minus 2 equals 0. And utilize the zero product property. As before, setting up two equations, first x plus 16 equals 0, and second x minus 2 equals 0, and solving each of those independently. On the left, we find x equals negative 16 to be a solution, and on the right, x equals 2. The only reasonable solution is 2. Note, negative 16 doesn't make any sense in terms of the measurements of this photo. So the outer dimensions of the frame are 2 times 2 plus 11 inches by 2 times 2 plus 17 inches, or more simply, 15 inches by 21 inches. Your turn. In problem 4, suppose the total area of the frame and photo is 391 square inches. What would the outer dimensions of the frame be?